So we introduce this when a ray of light passes through different medium, then refraction takes place. That we show with the help of diagram. Like if we have first medium is air, the other medium, let's say water. This line interface is dividing the two medium. Then we show it like this. We draw a normal perpendicular. It strikes like this. Let's say it has certain angle of incidence. Because it is coming in the denser medium, so it gets closer to the normal and vice versa. So getting closer to the normal, we write speed of light, which is c, is given by frequency multiplied by wavelength. Okay. So in this process, what happens? Actually, speed of light is something which changes. Either of the two parameters, like frequency, either frequency or wavelength will change. Frequency is something which is all about energy. So frequency remains constant in this process, but wavelength changes. And so this bending of light takes place, or change in path of light takes place. Okay. Okay. Now let us do Snell's law of refraction. Snell's law of refraction. Fine. Like we did the laws of reflection, similarly Snell's law of refraction or laws of refraction. It means the first part is the ratio of sine angle of incidence, sine I, divided by sine angle of refraction is always a constant. And this constant is represented by small n. Somewhere it is written as mu also. So this ratio is always constant, and this is called Snell's law of refraction. Okay. Okay. And the second one is called this ray of light is what? Incident light or incident ray, and this is refracted ray. Okay. And this is normal. So very similar to the laws of reflection, that incident ray, refracted ray and normal all lie in same plane at the point of incidence. Okay. So incident ray, refracted ray and normal lie in same plane. Fine. Lie in the same plane. So this is law of reflection. Then another term which is called refractive index. Refractive index. Okay. When we talk about refractive index, it means this is also symbolized by small n, which is ratio of speed of light in vacuum to the speed of light in a medium. Okay. Speed of light in vacuum. This C represent speed of light In vacuum. How much is speed of light in vacuum? Aryan? 8 what? Meter per second. And this is speed of light in a medium. Okay? In any medium. So all of you write a question. Question is find speed of light in a medium. All of you write a question. Find the speed of light in a medium having refractive index 3/2. Having refractive index 3/2. That's it.
Sir, can you repeat?
Find speed of light in a medium having refractive index 3/2. So all of you see to it. We'll be using the formula this since n is equal to c by v. We are told to find this v. Therefore, v would be c divided by n. C is constant 3 into 10 raised to the power 8. N is given, which is 3/2. Now, if you solve this 3 and 3 cancelled, this 2 will go in numerator. So it is 2 into 10 raised to the power 8 meter per second. This would be answer.
Yes, sir.
Okay.
Yes, sir. Okay.
Now, can I clear this board?
Yes, sir. Yes, sir. Yes, sir. Okay.
Now, like we did for reflection, we need some devices like plane mirror, spherical mirrors, and all. And do you know when we talk about the mirrors, mirrors are used in daily life also. Not only plane mirror, spherical mirrors also. If you see the concave mirrors and convex mirrors, these two are very common spherical mirrors and widely used, like to see the traffic signals in cars and other such automobiles. The convex mirrors are used because convex mirrors forms erect and virtual image, and it is easier to see the wide view of the traffic or other such area in small mirror. But if you need larger, bigger image, right, then concave mirror is used, like in beauty parlors, saloons, and other such places. Concave mirrors are used. Okay. Similarly, for refraction, we need to have some lenses or spherical lenses. There are two types of lens. One is called convex lens. The other one is called concave lens. Although there are some other lenses also can be manufactured, other types of lenses, but that is not required right now. So when we talk about lens, lens is basically a transparent medium having at least one surface which is curved. So one is called convex lens. The other one is called concave. If you draw a diagram for convex, it is basically like this. And so far concave is concerned, it is like this. Okay. So what is the fundamental difference fundamental difference is that in case of convex lens, the central part of the lens is little wider as compared to the edges, top and bottom. In concave, the central part is thinner as compared to the top and bottom. Okay. Now, like you did or you are told to do that, see all the ray diagrams there in the NCRT. There were how many ray diagrams for mirrors? I think eight ray diagrams. Similarly, you will find 8 ray diagrams for lenses also. 6 for this convex and 2 for this concave. So practice those diagram. Better you draw, better you use A4 size sheet. Okay, plain sheet, and then scale and pencil, sharp pencil, and then you practice. Then you can learn those diagrams. Like you did in mirror, over here also we have, which is called lens formula. What? Lens formula, basically we write it 1 upon f is equal to 1 upon v minus 1 upon u. There it was plus sign, 1 upon v plus 1 upon u in mirror. In lens it is minus sign. This is the difference. Okay. Okay.
Yes, sir.
So far, sign convention is concerned. Sign convention is same as that of mirror, which means there we discussed 3 points. First was the central part of a mirror, which is pole. Pole is taken as origin, or any distance is measured from origin. Then second one was the distance measured in the direction of incident ray is positive and vice versa. And final was the distance above principal axis, positive, below, negative. Same thing over here. No change in that. Okay. Now, the next one we take over here is the magnification. There also we had taken magnification, right? What was that formula? Anyone? Magnification. It was not v by u, minus v by u. Minus v by u. But over here it is v by u. There minus sign is must. Here minus sign is not there as per sign convention. Also we can equate this with height of image divided by height of object. Okay. So this becomes formula for magnification. And then same way we can apply this formula in numericals. Question fine. So let's try to apply. All of you write a question. Question is a convex mirror, sorry, a convex lens, of focal length 20 centimeter. A convex lens of focal length 20 centimeter forms magnified image of an object forms magnified image of an object which is 2 times as that of the object, which is 2 times as that of the object. Find the position of object placed find the position of the object placed. That's it. 2 minutes for you to think and try without talking. Okay. Okay. So all of you cross check it. I am doing. All of you cross check it. Since magnification is given, so we'll be using the formula for magnification, which is since m is equal to v by u, which means 2 is equal to v upon u, which means v is equal to 2u. Okay. So this is the relation we have, and we'll be using this relation. Fine. So if we use this relation, v is equal to 2u, and then write the formula that 1 by f is 1 by v minus 1 by u. F given is 20. Now sign convention comes into picture. The length given is the convex length. So in case of convex lens, focal length is always positive. So we'll take plus 20 is equal to 1 upon v. Now v is unknown, but v over here we have a relation 2u. So let's write minus u. So it will be how much? 1 upon 2u minus 1 upon u. It gives us minus 1 upon u. And then by cross multiplication you get u as minus 20 centimeter. Okay. Minus 10 or 20. Okay, it will be 2u now.
Minus 10.
Yes, yes. So 2u.
Yes, sir.
So u will give us 10 centimeter. Minus 10 centimeter. Fine. Minus 10. So which means if we keep length, then we can have this. This is very much possible. Sometimes you are told to draw this with the explain with the help of diagram also. So we can show with the diagram as well. Like if you look into it, it can be like this. Draw a lens, and let's say you draw this principal axis. Then mark this point as focal length, and focal length given is 20 centimeter, right? And then object placed, we are getting a 10 centimeter. So if it is 20, position of object will be exactly at the midpoint. So up to this is minus u, and then parallel line pass it through the other side, which is focal length, and then from this point, and in this process inverted image, which is magnified one, is obtained on the other side, and better you name the object and image as well. Like if it is AB, the other side it will be A dash B dash. Fine. So while drawing the diagram, you need to take care of the scale also. That if f
Yes,
is
sir.
20, it should be exactly at midpoint 10 centimeter, and accordingly v will be 20 as well. So other side. And then, so this is very significant question in NCRT as well, CBSE as well. Fine. Hello.
Yes, sir. Yes, sir.
So this way you can practice some numericals at least first in NCRT, which is solved, unsolved, and then the next is the applications of these mirrors, sorry, spherical lenses. So, what are the different applications and why? Applications of lens. Let us take first convex lens. Convex lens. And the other one, concave. Okay. So, in daily life, where you can see this use of this convex lens, whenever you need magnified image, there you will find convex lens is used. Okay. So to create magnification in the image, like the dentist also uses this convex lens. But if you need virtual and erect image, there concave lens is used. Hello,
Yes, sir. Yes, sir.
right? Then along with lens, in the lens part, one thing is significant, which is called power of lens. What? Power of lens. Power is generally associated with these specs we are using. Specs.
Yes,
When you go to the doctor, then doctor, after examining the human eyes, then they come to conclusion that there is some problem in the eye and therefore some sort of lenses are required. Some types of lenses are required. And accordingly, they tell us have this spectacles of this much power. Okay. So power is basically converging power of a lens, right? How much it can converge or diverge to form an image of an object. Basically, its measurement is reciprocal of focal length mathematically. What? Power is P is equal to 1 upon F. Fine. And when we call this P 1 upon F, unit for power, MKS or SI unit is diopter. DIOPTER. Okay, capital D we are using. Then, because this is SI unit, power, diopter, so focal length is also taken in meter, which means if focal length is given in meter, power would be in diopter. If it is in centimeter, we need to convert it into meter. Okay.
yes, sir.
Now, since it is associated with the human eye also, if you take overview of that, generally there is a term called power of accommodation. What? Power of accommodation. When the ability of human eye, reduces or decreases to adjust its focal length according to the objects kept, then we need to have some sort of specs. Okay. So this power of accommodation is something which is unique. In case of human eye, it is done with the help of ciliary muscles, which is connecting the eyeball with the brain. Now, if this ability of ciliary muscle reduces, then defects of vision occurs. And that is why there are in general there are two types of vision, although there are five types of vision total. First one is the myopia, then we have hypermetropia, then night blindness, then we have color blindness, right? So our focus is basically on two, myopia as well as hypermetropia. Myopia basically happens to the kids of your age. Means sometimes you are difficult to see the objects, see the letters written by the teachers on the board, right? Means you are unable to see the distant object clearly, but can see the nearby objects clearly. Okay, are you listening? So we can understand it with the help of the diagram. So look at the diagram. Defects of human eye. Okay. First one, we call it myopia. Can you see this? Try to understand. See the first diagram. First diagram is said to be the defected eye. What? Defected eye. In defected eye, what is happening? Can you be quiet? Time is about over. Defected eye. In that this case, what is happening? The object from light from distant object which are parallel are striking the reaching into the human eye, the eyeball. Then after converging, they are reaching or intersecting before retina. Since it is not reaching at the retina, so image can't be seen. This is the defected eye. So what has happened? The ability of eye has reduced to converge the images at the retina. So what is happening? How it is corrected? We have this lens is concave lens. Concave lens is used to correct this defect. Correct this defect. So when these two rays are entering, now after that you see when it comes out of it, they are diverging, moving away from each other, and finally striking the eye lens, convex lens, and then they converge to form it at the retina. Thus seen. Okay. Similarly, Similarly, if you see hypermetropia, in this case, if we have an object is very close to human eye, let's say O, light is striking the and reaching to the eye, but in this case what happens in retina, and so image of the object is not visible. Okay, now if we take corrective measures, then we are using some lens, and that lens would be convex lens because curvature has reduced. So what is done, when these lights will be reaching from the nearby objects, the first these light will converge, being closer, and again getting the natural human eye, which is also convex. So again it will converge, and in this process they are able to reach at the retina of human eye or human brain, and thus image can be seen. So by using convex lens of suitable power, this defect can be overcome or removed. Okay, so this was the basics of these two defects, myopia as well as hypermetropia. When we talk about, this diagram is drawn. Yes. So far, other types of defects are concerned, like having said that, the one which is the presbyopia. So generally it happens, it is said to be an old age that a thin membrane develops. Meeting is about to over, right? Zoom will get over automatically. So be attentive. So thin membrane develops, and after that, people are unable to see things around, and finally becomes almost blind. It is corrected by using the surgery. Nowadays, laser surgery and different type of technology available to correct that disease, and then person can be normal. Next is the color blindness. Color blindness is basically in that the person cannot see the particular color, right? Although that is genetic disease, so there cannot be cure, and in daily life it may not be, people may not find that he is having some defect even.